Science for many years worked on analysis, break things down to tinier pieces. And it gives rise to the classical view of reductionism. Okay, in the end, we end up with atoms and molecules. And there are more fundamental levels, but for chemistry, biology, living systems in general, you're not really going to need anything more fundamental than molecular level science. The problem becomes then when you start to go in the other direction. It makes perfect sense to say biology that never contradicts the laws of physics. On the other hand, trying to build biology out of the laws of physics is a real problem, because that's where extra levels of information, extra levels of complexity start to kick in. And as they do so, we like to think there are emergent sets of laws. I mean, if there are laws of ecology, for example, those are a set of emergent principles. Physics doesn't have laws of ecology. Physics has the Schrodinger equation. Physics has thermodynamics. Chemistry. I make the joke to my students. Chemistry, the typical chemistry explanation, we have 3 little rules and then we have 42,000 exceptions. Because the laws of chemistry are really rules of thumb. They're really local phenomenological explanations of subsets of phenomena. And when we have tried in recent times to go to more generalized theories, where we've ended up is these massive computational computer programs, okay, that you feed in the basic parameters of a molecular system. You hit the button, the computer does trillions of pieces of arithmetic, and physical properties emerge at the other end. Now that's a very useful method for practically doing chemistry to predict the behavior of a drug molecule, for example, but also provides nearly no understanding of what's going on. Now, the one time that does work is it effectively becomes numerical experimentation. Okay, numerical experimentation simply means that you have simulated the system, okay, and you analyze the data that comes out exactly the same way you would analyze some sort of microscopic subatomic video camera taking pictures of the system. So a biochemist did this once. There was a talk of a base pair flipping out of a DNA strand. So remember, the DNA is a double helix and the rungs of the ladder are 2 base pairs coming in like this, and people were talking about could a base pair fling out suddenly and face the other way. Well, it had never been seen experimentally, because that's a hard thing to picture. But people ran these massive simulations, and sure as hell, on a number of these things, you would periodically see the base pair go flick. And then it would just run around for one come in. And by studying the simulation, we were able to better understand the physical properties of that system and begin to go looking for it happening actually in nature. But notice those aren't laws of nature. They're not the way you come up with F equals ma or the Schrodinger equation. Okay, these are simply studying more complex phenomena. To some extent in my area, the word we use or the phrase we use to describe these phenomena are called non-equilibrium thermodynamics. The funny part of that, any field that starts off with non, okay, means that we had an approximation that we really liked, or we had a constraint or a restriction we really liked. In the case of thermodynamics, we let things take their time and come to their final state. Thermodynamics was really good at predicting you start here, and if you just let everything happen, you eventually come to this final state. What equilibrium thermodynamics is terrible at is what happens in the middle. How do you get from point A to point B? Okay? The difference between a state function and a path function. Non-equilibrium thermodynamics tries to deal with that. What's remarkable is how little progress we've made in terms of actually conceptualizing how things work. The progress we've made is simply based on the fact that computers have gotten better and we're better able to simulate these sort of things. But laws don't really have those. Okay? And the natural sciences don't feel as compelled as the social sciences. I mean, the social sciences can't explain things. they have nothing they can do. I mean, the natural scientists can sit back and say, well, we can understand things at the molecular level, and we'll just characterize, describe things at whatever level we want, and that's enough information for the engineers to make stuff. But laws, okay? There are really no emergent sets of laws that are laws in the sense of the laws of physics. And that's really where everybody's looking now.